afternoon, everyone. My name is Giulia Conforto, and I'm welcoming you to this online tech tutorial titled Tools and Data to Decarbonize Cities. It is going to be a hands-on tutorial where we're going to guide you through a number of tools that we have developed in several projects and can be very useful to decarbonize cities. So to develop some local heating and cooling strategies, to access open access data sets that are located on various hubs and how to use them and what are the advantages and how you can reuse them in your daily work. I would like to have a chance to first share my screen, if that is possible. Yes. Okay, I'm sharing my second screen. And can you see correctly my presentation?
Yes.
Perfect. Thank you so much. And I would like to also take the chance to let the rest of the panel introduce themselves. So I'm here today with Dr. Mostafa Fallahnejad and the engineer Aadit Malla. Mostafa, maybe you want to say a couple of words about yourself.
Yes, thank you, Giulia, for the introduction. I am a senior researcher at the Technical University of Vienna, and also I work as a senior researcher at IFIG Energy Research in the field of heating and cooling planning. And I'm happy to introduce you one of the tools today. Thank you. Adit?
Thank you so much.
Thank you, Giulia. Hello, everyone. My name is Aadit Malla, and I am a research associate at the Technical University of Vienna. And I work mostly with regards to heating and cooling planning. And in today's session, I will walk you through the CoolLIFE tool, which is an online platform dedicated to cooling planning, so directly focusing on from the perspective of cooling. And yeah, maybe I'll go into details later. So I hand over back to you, Giulia.
Thank you so much. And my name, again, I see there are new participants that just joined. Now, IFIG is a small research in Vienna, which focuses on the decarbonization of cities and buildings. So we develop custom studies, scenarios, and European projects, national projects, reports, and other consulting works for the energy transition, but specifically for the buildings, heating and cooling, and district heating and cooling. My field of research is mostly the financing of the energy transition.
Giulia, your connection doesn't look very stable.
So how you what public schemes people and let me look the reason of oh, I'm sorry. Yes, actually, okay. Let me just give me a chance. Is it better now?
Currently,
can you hear
yes.
me better now?
Yes, currently, yes.
Okay. Yeah, very technological solution. I moved my phone close to the window because the hotel connection was not working much better. It's a very windy day today in Munich, unfortunately. So let's see if it works. Otherwise, I will switch off my camera and maybe that can help. I will hand over first to Mostafa to show us the Citiwatts tool, which is an evolution of the hot maps tool. And he will explain you how that works, what kind of open access data sets it comes with, what kind of functionalities it offers, the calculation modules, and how we intend it to help your work in developing sustainable energy strategies and studies. Then Aadit will jump in and will show us the CoolLIFE tool, which is a similar tool, but it's specifically developed to meet sustainably a growing demand for space, cooling in buildings. And then I will show you the CoolLIFE Knowledge Hub and all the resources that are available there. And from there, we will have a look at a EU-27 country mapping of financing instruments to decarbonize the building stock. So heating, cooling, district heating and cooling, building efficiency, and so on, and the studies that were extracted from it. One was for CoolLIFE, specifically on space cooling, another one on specifically on geothermal district heating and cooling for SAFEA, and how to access the full mapping that is available on Zenodo and on the Renewable Heating and Cooling Accelerator. And then we will have hopefully some time for some questions or practical application. Having said that, I would stop sharing my screen and hand over to Mostafa for the first tool, Citiwatts.
Thank you, Giulia. Now I will try to share my screen. Okay, I hope that you can see my screen now.
Yes, we do.
And also my slides. Let me check.
In the meantime, Mostafa, before you start, I have a question for the support. If the participants want to pose any questions, can they write them in the chat while we are talking? Or can they unmute themselves? How is the session managed?
Whatever you like, they can write it down in the chat and you can read it and answer it later.
Okay,
yes.
Perfect. Thank you so much.
You're
so
welcome.
if you have any questions that are specific to this tool, write them in the chat and we will see if it's time to address them right at the end of the tool demonstration or at the end of the whole session if they are broader questions. Please, Mostafa, back to you.
Yes, thank you. Well, as mentioned, I will demonstrate the Citiwatts toolbox. Basically, I will give a brief introduction to the hot maps and Citiwatts, and also then it will follow with demonstration of the tool. Basically, it all started from Hot Maps platform. It's a platform where the energy planners can have a look at and have access to a large set of European open access datasets, as well as a lot of calculation modules with which you can manipulate datasets and also get new indicators. The point is that the Hot Maps platform was developed originally for research purposes and was on a technology readiness level 7, and we decided, following the successful experience of Hot Maps platform, to bring it to a higher technology readiness level and become one step closer to the market-ready product. And in that sense, the ERANET project, OpenGIS for energy transition, started, and we now work with a new name, Citiwatts, for the platform. And you see in the screen the list of consortium members. So generally, what we are working on to improve, or we have already improved, is basically to make an adjustment in core calculation modules so that they are better fitted to the needs of the users and also improve overall functionality of them. Additionally, we have new modules covering district cooling, which was not part of Hot Maps platform. Furthermore, we have added calculation modules on mobility, and also we have sector coupling in the platform now, or at least it will be part of the platform. Besides these improvements, which is rather most relevant ones for the user and also users directly work with, we had a lot of improvements in the usability and user experience, as well as technical improvements in the platform, which also helps the developers to just take the platform and make whatever they want with it, as the whole platform is developed with open source licenses. Saying that, I will navigate to the platform itself. So the address to the platform is citiwatts.eu. And once you open it, you get a disclaimer page with explanation on the project and also the needs for browser. Once you agree with the cookies and the disclaimer, then you can have access to the platform. Inside the platform, basically, you see the European map as this toolbox is developed mainly for European countries, even though it can be expanded to other regions. But we have provided data for European member states, and therefore you see first when you open the platform, the map of Europe. You have the option to look into different administrative boundaries, and as well as just zooming into hectare level, and with different background maps, which should make the view of the maps easier. But the most important part is here on the left, where you see menus, list of the layers, which are categorized in different categories and classes, like building related data sets, industry, population, mobility, renewable energy sources, climate, and electricity. And all these data sets can be visualized. So I navigate to Vienna as an example. So once you click on a layer, you can visualize this data in the platform. You have the option to download the datasets fully, or if you are in a boundary and you just are interested to a certain region, you have the option to select the dataset only for your selection with clicking on this layer. The meaning of the colors are provided in the legend, and also you have the option to navigate to the repository of the datasets to get more information about the background of the data, all the assumptions behind it, and have access also to developers or providers of the datasets. That's, of course, one important part of the platform, which provides basic data for doing studies and planning. But the platform is not limited to that. There is an option to have data sets from yourself on the platform and visualize them and work with other functionalities of the platform. And that can be done through having a user account. So basically, you can create a user account. You just need to have an email address. You just give mine. Sorry. There is an option, of course, to register one. You just need to provide your name, family name, and email address, and accept the privacy terms. And that's very easy. You get a confirmation email and create your account, or you just once you create it, you just log into your account, and you can have access to the list of datasets that you already have. And you have the option also to select from a list of datasets and just upload the layers that you're interested into the platform and visualize them inside the platform, everything online. Once you upload a layer, you have, of course, the option to share your layer with other colleagues in the same company. So always it's seen if you have an email with password of, for example, tuveen.ac.at, so if I share it, anyone else inside Tuveen would be able to look at that data sets. Therefore, this sign P is for private and S is for shared data, and you can see which data I have here. These data are secure, so it will not be shared with anyone else if it's private. You can see the list of shared layers here. Anytime you are not interested to have them on the platform, you have the option to delete them. It's very simple. You just go to your files list and just press on delete icon, and then it will be deleted from the platform. Another important functionality that we have is like selection tour. So once you are in a selection tour, of course, you can select the regions depending on the administrative borders, but you have the option to make a free selection. For that, you need to be on a hectare level, and there are like different types that you can choose and make a selection. And once you have done your selection, you can press on load results, and there you can see list of indicator for your selections and for the list of the layers that you already selected. For example, in this case, I have only heat density total has been selected. If I go further with other layers like population, then not only I will get the heat density total, but also the population, and so on and so forth. Another list of very important functionalities that we have developed in course of the project is, or are, calculation modules. Here we have categorized them into two categories, basically two main categories of demand and supply, and we have list of standalone calculation modules which work, of course, independent of the online platform, but we found them useful for our stakeholders and also for our users who are more expert and more interested in working with additional functionalities which are not provided in the online platform. And of course, those standalone calculation modules need know-how of the GIS and also programming. On a demand side, the list starts with like scale, heat density, and goes on with heat demand projection so that you can have estimation of the future heat demand, identification of district heating potentials in a sophisticated manner with economic indicators or in a simplified manner. There are options for electric vehicles modeling. And on the supply side, we have modules for renewable energy sources, for excess heat, and also for dispatch of heat sources. So starting for a basic heat planning, for example, you may want to go back and select the heat demand density layer on the platform. Also, I just close this. Reason I just select the city of Vienna. And what I can do is, for example, now have a look and see which regions of the city are suitable for district heating and under which conditions I can run or connect the areas to the district heating systems and under which cost. Basically, it's good to have an idea of the current and future situation in the city. The basic idea is that you just scale this heat demand density on the map. You just need a expectation of demand reduction in the future. So let's say that in the future, we expect that the demand will decrease for 20% in Vienna in the year 2050. And I just can run the model. And once the model finishes the calculations, I can see what would be the demand, future demand with the multiplying factor. This is a very simplified approach. There are more sophisticated approach with demand projection module, where I need to provide indicators on population growth, on the renovation of the buildings from different construction periods and so on. But for this short webinar, I skipped that one. So the result of the calculation will appear in the layer list. If I go down in the layers menu, I can see that, okay, here there is a new layer coming from calculation modules, and I have the option to download this layer. And once I have downloaded this layer, I have the option to also upload it to my user account so that I can use it for further analysis. And what I do is just go and pick that one and upload the layer. It takes a few seconds, and once it's there, then I would be able to see the layer which is here. So what I need to do in order to clarify it, just to disable these layers. And here is the output that I could see. And then the next step is, like, for example, identifying district heating areas, and based on economic parameters. What we need to do here is to provide certain information related to the cost functions. For example, which cost components do we expect for the district heating systems? There are some default values provided in the platform, but there is an option to provide them manually. You just need to have a plan. For example, I would say I'm planning to invest on district heating grid systems from now 2024 to 2050, and current district heating market share within district heating areas is like, you know, 20%, and it will increase to 50% in the future. And my expectation is that I am interested only into the regions that have at least 7 gigawatt hour of heat demand at the end of this period. And I just want to cherry pick all the hectare elements that have a heat demand of over 150 megawatt hour. And I'm not going to spend more than 25 euro per megawatt hour for the grid systems. I expect a depreciation time of 30 years and interest rate of 5%. There's also the option to limit the annual expansion of the grids. So you can say that the city does not have capacity to build more than 20 kilometers a year. That can be limited as well by providing these additional input parameters. If you don't touch them, then this limitation will not be applied. And here, of course, you need one layer for the current situation and one layer for the future. As you can see, it has been picked already from the list that I have, and I will use that for my calculation. With the timestamp, I can make sure that if this is a correct layer or not. So guess this is the correct one. So I run the model now. Seems that I picked the wrong one. Check. All right. That's not good to have so many layers. So I upload the layer once again to make sure I rename it. And I need to see if the layer has appeared already. Yes, it's there. So I'm sure that it's there. I come and repeat the steps once again. Problems of demoing or live demo of a platform. So again, I give the input parameters related to the connection rates, and also the minimum demand in each pixel, the cost, depreciation time are fine, interest rates also fine. Then I need to grab the right layer. Okay, now I understand why it caused a problem. So maybe it's better to demonstrate it through our development platform.
So Mostafa, can you explain us what the issue could be when uploading a layer if it doesn't show? So we saw that it takes a second to upload a new layer and save it on your profile. Then it's better to refresh the tool to have it.
No, basically this is currently we have a new release on the platform, and maybe some of the functionalities do not appear. So I need to have a certain type of the layer for the upload, and I don't see that type of the layer currently. That's the main reason that the layer does not appear here. Yeah, it's as it is. I would do the calculation with a simple approach, so it's not a big issue. Basically, should be resolved soon.
Because there is always a default dataset that can be used, right? So even if you don't have the layer that you've just developed,
that's true. That's true, but it's under the development, so it can happen.
Okay.
We will have the release in a few days, so it should be resolved till then.
Okay, in a few days there's a new release. Okay, thanks.
Yes. Yeah, I just go the simple approach where the economic parameters are not given, so there is an option that we just work with thresholds and give the thresholds, and we run the calculation module for the selection, and then we get list of areas which are interesting for our analysis. Once these parts are there and we can see the district heating areas, of course, it can be followed by looking into another calculation module. So here we see the overall potential in the city and the share of it. But anyway, it's possible to continue with the analysis and going to a supply module where you can see which supply option can be used to deliver heat to these areas. So the very first and the most important parameter that needs to be given is the demand in district heating areas, and also including the grid losses. So I come up with 6 terawatt hours, and just run the calculation module to see which options it provides. It's a complex calculation module which details of different technologies needs to be provided from their investment to their running cost. There are 2 options that can be used. One option is investment mode, and the other one is dispatch mode. Anyway, it's possible to run the module for both cases. If there is like a case that the decision is being made, it can be done on invest mode. If there is the option that you already have certain technologies, then dispatch mode would be the most suitable. And the outputs provide like a combination of different technologies, and also there are some visualization on the platform which you can see what are the levelized costs for different technologies. CO2, O&M, and also fuel cost. Then if there's a ramping cost, in this case, I did not provide it any. So a long list of outputs, and all those outputs can be exported to a local computer by pressing on this export button. So a CSV file will be generated and they can be exported. So as you can see, the product is still not market ready. We are working actively to improve the product and bring it closer to the market, but still there are potentials for improvements. The whole idea is that the platform is being used by energy planners. Some data have been provided to them to ease their work, but if they have their own data, they have the option to use them to make the planning. And they can do cost-benefit analysis, compare decentral options with central options. And this is that the platform offers. It's for free, and we currently do not have any plan to make any membership fee for using the platform, but is there to be used.
So
I think that was it from my side. If there is any questions, I would be happy to answer.
thank you so much, Mostafa. That was actually very interesting. So yes, the platform is open access. All the data sets are open access. There is a wiki that supports the user across the layers and the various functionalities and the use of the calculation modules. Can you tell us when you will start the capacity building of this project? So when one of the participants could attend a complete training to see how all the calculation modules work, if that is already planned?
Yes, good question. Thank you very much, Giulia. There are like capacity buildings on the pipe. So our focus countries are Austria, Germany, and Denmark, and we, as well as Switzerland. And in each of those countries, there are consortium members who are active. We will have our next capacity building actually in Wiesbaden in Germany, and it would be a physical capacity building for energy planners in federal state of Hessen.
Very interesting.
It would happen in beginning of the year in January. Actually.
Nice. So that's the next one. And then you plan to also have some hybrid ones because there are potential users all across Europe, right?
Definitely, we will have some hybrid trainings. There are no concrete dates for those hybrid trainings. One aspect of it also that we will offer as like courses for the universities, but they are all on the pipe and will come next.
Very nice, very nice. There was one question in the Q&A which actually asks what are the business application of this tool. So the previous tool, HotNots, which was a simpler version, was already used mainly to draft local heating and cooling strategies. So that was done by local administrations, municipalities, regional energy agencies, energy planners, professional energy planners. It could be used by utilities, energy companies, distributing companies that were interested in identifying new areas to explore. Of course, this is not a tool that has the detail of the single building level, but it identifies an area where it's worth focusing a more detailed analysis. And the advantage is that it always comes with a series of default data sets. So even if you are lacking precise data, a pre-feasibility study can always be done. And then you can focus only on that specific small area for a more detailed are there any other business applications that you see in the Citiwatts version? So since this version has upgraded functionalities and new calculation modules.
Yes, thanks for the question. Well, we have like two streams of customers. One stream is like energy planners and municipalities who are interested in heating and cooling planning. The basic idea of the platform is that you can work with it without having programming knowledge and without need to know very much about GIS. So it's very useful inside the companies to have such a platform, and city planners usually need such a tool to facilitate their plannings. Since the platform is fully open source, it can be used by them. But often we have seen that they need consulting to help them either to have dedicated platform on their servers running, or they need support with the energy planning. And that's where we see the potential for business ideas. Basically, we would like to keep the platform open source so that everyone can use it, but we see the potential that many municipalities needs the consulting from us, and in this way we can help them to make heating and cooling plans.
Okay, I see. So I don't know if any of the participants is now going to lead, because there are several tech tutorials at the same time. Before you do, if you plan to switch to another one and you're not planning to stay for the next tool, I will share a link with a feedback survey. It's a short feedback survey where you can tell us what you think about this tool and the training. I will share it again after the next tool and after the whole European 27 country mapping of financing instruments. In that form, you can leave your email if you would like to be recontacted once. So I'll stop my video. Sorry. Once the full capacity building program has started. And thank you so much, Mostafa, for your contribution.
Okay.
If there are any other questions, please feel free to write them in the Q&A or in the shared chat. Now we'll hand over to Aadit for the next tool, that is the CoolLIFE tool, driving a sustainable future in space cooling.
Yep, thank you, Giulia. Yeah, I will just try to share my screen first. Yes, do you see my screen?
Yes,
okay,
we do.
Yeah, thank you. So, yeah, hello everyone. Now I will be talking about CoolLIFE, which is kind of a continuation from Mostafa's presentation. So CoolLIFE platform was developed within the CoolLIFE project, which is a project funded under the LIFE program, which started late 2022, and it's still ongoing and goes on till end of next year. And here the idea is to, as I mentioned earlier during my introduction, to develop a platform which allows a more detailed assessment and analysis of cooling, considering that cooling in the overall energy sector is a topic that has not been looked into much in detail as of now, and also considering rising cooling demands associated to increasing global temperatures, also improved affordability of building occupants to be able to afford cooling appliances. This has become more and more of an important topic in the overall energy sector. So now I'll talk about how we have developed the CoolLIFE toolbox and what are its applications. So as with the Citiwatts toolbox, the idea here is to have a detailed assessment of the demand, supply potential, and also provide a possibility of visualizing the data spatially to see where more interesting areas for developing cooling supplies could be more interesting in a city. So I start with showing you the platform itself. So the link here directly takes you to the CoolLIFE platform with the toolbox, which lands you to the disclaimer page, basically giving an overview of the project and on accepting the cookies. And also we have here the list of members of the consortium. So the consortium comprises of research organizations from all across Europe who we are working together to develop this platform. And once you choose to accept disclaimer, you are taken to this page, which is kind of very similar to Citiwatts. It's because we developed it. So it has been developed on top of Citiwatts. So as an additional direction in which the Citiwatts toolbox can go for analysis. And in general, the layout is for the CoolLIFE platform is quite similar. So I wouldn't go much into detail on these aspects, but rather focus more on the calculation modules which are dedicated for the cooling assessment. So just to give you a quick overview, the CoolLIFE platform was or has been developed or is still under development, basically to carry out planning and also for data visualization and more detailed analysis. And we see potential applications of this toolbox, for instance, on a national level, developing the national energy climate plans or the comprehensive assessment on a national level, or also for more local level strategic planning. So with our experience working in the cooling sector, we've realized that there is a very minimum availability of knowledge and experience on local levels with regards to planning for cooling specifically. So we see this tool as a major contribution towards better planning for sustainable supply in the cooling sector. So that was the main focus or reason for developing of this toolbox as well. And along with the toolbox, I would also point to another parallel platform, or rather the wiki of the toolbox, which is quite important for a new user who is willing to, or who's trying to understand the use of the CoolLIFE toolbox. So I would rather today's presentation go hand in hand parallelly within these two platforms. So I'll be kind of switching between the two. So the wiki basically provides us an overview of how to use the toolbox, what are the different calculation modules for, and it provides examples on how a user can use these calculation modules to generate desired results. So to start with a quick overview, just on the top, we have this panel similar to the Citiwatts platform. From on the left here with the CoolLIFE, you are directed to the CoolLIFE website, where you can find different resources that were developed over the course of the project. Top here, the go-to place is basically, as Mostafa showed, we can identify a potential location where we want to have our analysis. So that's quite simple. And also, since the CoolLIFE tool is still, let's say, on its first versions and is still under development, the survey button here provides us for a possibility to get feedback from the user, which I think is quite vital at these early stages of the development of the platform. And yeah, we are continuously working on improving the platform also, and integrating suggestions and requests from the user. And on the right, we have the possibility of also similar to Citiwatts, choosing different different regions that we want to work on, starting from not zero, going down to the hectare level. And also for more visual aspects, we have the possibility to switch between the road and the satellite layers. And again, the tools are quite similar. You can select regions based from the toolbox, and also we have layers, which are quite similar to Citiwatts, but for more focus here on the CoolLIFE platform would be layers, for instance, focusing on the cooling demand density. So this layer is basically, for instance, showing us for different cities across Europe how the cooling demand is distributed across the city. And based on this, maybe we could, let's take Prague here, for example, we could see how the distribution of the demand is, and and then identify locations which could be more interesting or economically feasible for having more detailed assessment on cooling supply or improved cooling supply. And on top of that, also we have of course, the gross floor area, for instance, the building volumes, and also renewable energy potentials. And also on the climate side, more interesting for the CoolLIFE platform, we have the distribution of the cooling degree days, which are also used for some of the calculations. So basically, from the layers, we are able to visualize spatially how demands or potential working areas would look like. And then I would directly jump into the calculation modules, which I think are more of the interesting parts. So right now, since the platform is under development, we already have some calculation modules, which are here categorized on 3 categories. So we have the ones focusing on the demand, the one focusing on policy, and the one focusing on finance. We still have some calculation modules which are under development and will most likely be on the platform very soon. So to start with, so as you can see, all the calculation modules right now are, you can obviously choose them. So once you choose a working area, once you choose a working area, for instance, here I chose Prague, the calculation modules are become basically more usable. And then maybe I'll show you what happens to each of the calculation modules going one by one. So the first one is on the space cooling demand. This is very similar to one of the calculation modules we saw in Citiwatts. So the idea here is to see how the demand would, how the demand projection would look like in the future years, based on which, on one hand, we can visualize this demand distribution or the increase or decrease in demand. And on the other hand, this could provide an input to other calculation modules which can do further detailed assessment of these demands. So as I mentioned, so for instance, here we have, so if we go to the tools and load layers, so we can see the total amount of cooling demand currently in the city of Prague. And basically, this calculation module allows us to see, so for instance, we say cooling demands are increasing. So let's say the cooling demands increase by 3-fold up until 2050. So we can run the calculation module here, and then they should probably give us a new layer, which shows how the distribution would look like under given assumptions. So if we go back and of course we can see the total demand, how it has increased over this time period, and also going back to the layers, it gives us this new layer which was generated from the calculation module run. So basically the demand is basically here on the map, shows how the demand increased under our given condition. So also, we have tried to make the calculation modules as simple as possible, keeping in mind the wide variety of users we expect. We are expecting users with minimal technical knowledge to an extent of users with who can go much into depth with the technical assessments. So we have tried to make the calculation modules fit the needs of both these types of users. So as with this regards, with minimal input, the user is able to generate results which are usable for further assessment. So that was the space cooling calculation module, and so this was basically on the demand side, how demand forecast in the future would look like. And then we have the second calculation module on the economic feasibility, which basically also provides, starting from the demand, it looks into how demand would grow, and then also possibilities of integrating passive measures. So for instance, if there are policies developed on promoting different kinds of passive measures, for instance, having window shades or changing the set temperatures in a building, for instance, or changing the human behavior on how people adjust to increasing climates. So these scenarios can be developed within this calculation module. So the calculation module can itself be run on 2 different layers. Two different modes, so either on a national mode or a building mode. So if you go to the national mode, so we basically are able to assess potential scenarios and costs for these scenarios at different on a national level. So we have defined 3 different scenarios for passive measures. So basically here, no changes means So the buildings don't have any additional passive measures included in the geometry. So for instance, the shading or the shading in the buildings, let's say, remains the same over the time horizon until 2050 when we're calculating. But also we have the possibility to check what happens if these buildings switch to a more advanced level of measures that could reduce cooling energy. And with this regards, we can formulate 3 different scenarios, which are predefined based on literature, of course, and also details of which are available in the wiki, which can actually be accessed from here. So it takes you directly to the wiki page where details on, for instance, I'm talking about the scenarios here. So we have different scenarios based on the, let's say, the shading technologies, the window glazing, the night ventilation. So based on it, we have predefined scenarios, and the user can select one of these scenarios for passive measures. And also we have possibility, for instance, to define the active measures. So active measures meaning the supply technologies like air conditioning or district cooling systems. What are the actual technologies that provide it? And also here you can define to what extent the technologies diffusion takes place. And also here we can define the efficiency of the technology. So meaning that the technology efficiency at present day might be much lower, but in the future this might be expanding due to development in the technologies, and the user can also define this. And also the user is able to define different financial parameters based on which the economic assessment is performed. And so let's take, for example, again, staying with Prague, we can run this calculation module to see what results we get here. So basically, we can see the calculation module here. So it gives us an overview of the scenario described. So basically, based on our selection, we have a high efficiency of passive measures with moderate diffusion levels of technology and also high development of technologies. And this happens from the present day until 2050. And based on which we can see that if the scenarios or these passive measures and active measure changes were not made, then the base year starting from 2580 gigawatt of energy would increase to about more than 4,000 gigawatt of energy consumption for cooling until 2050. But with these measures, or if these measures are implemented, then we see a possibility that the demand could drastically be reduced to 800. So this makes quite significant difference, and we can observe the impact of these passive and active measures on the demand. And also the calculation module provides us with the possibility of visualization. So how demand would decrease with our selected scenario against the baseline scenario when no changes would have been made. And also provides tentative costs on how much investment would be needed. So for instance, if we define scenario as such, then we would need quite drastic expense on the passive measures, which would be a major portion of annual costs, but also we would have costs on the operation of the active measures. But these are, of course, tentative costs based on literature data. And of course, if the user has more detailed data, then this can be provided as an input, and further, let's say, more accurate assessment can be done. But considering somebody who has no inputs on these data available, the tool already provides the possibility of doing a first level assessment, and also comparing if it makes more sense to invest or define policies on passive measures, or rather focus more on the development of active measures. And of course, the calculation module, this was just one run, and the user can, of course, download the results and develop different combinations of scenarios, which allows comparing different scenarios or based on the passive measures and active measure development, and then identify the best suited option for development of cooling policies. So this is more seen from the perspective of an energy planner who is developing cooling policies on a local or a national level. So I think this calculation model provides quite significant inputs for this. So that was one calculation module, and then again So maybe I move a bit further, and yeah. So we have other calculation modules. So now, which is more on, again, maybe we stick to, or maybe we move somewhere to Vienna, or yeah, let's try, let's say Budapest. So where we have the comfort lifestyle user calculation module. So here again, this calculation module provides the user with very important information on user behavior and what are the user behavior practices and lifestyle patterns that that dictate the cooling demand in certain regions. So basically here the inputs are quite straightforward. So the user can select what kind of data they're looking for. So if they would want information on how traditional lifestyles help reduce the space cooling demand, if they would like to see country-specific summer thermal comfort needs, or yeah, if they like to see interventions that could help reduce their cooling demand. So they can select a region. As per here, I select Budapest, and then I run the calculation module. So it basically gives us an overview of what are the user behavior interventions that could help reduce cooling demand in the specific area. So of course, this is based on a lot of literature review and data collection from different regions across Europe. And these are data which are, I would say, quite difficult to come by, but also have a very important role in planning, also for demand estimation. So the toolbox provides this possibility of accessing such data for further detailed assessment. And of course, this can be downloaded by the user for further assessment. And also we have the possibilities of visualization. So of course, depending on data, there are different aspects which can be visualized by the user, which gives quite a broad perspective on what can be done with the calculation module. Yes, and again, from user behavior, moving into a bit more technical calculations of calculation module. Now I move to Munich. Here we move into the technology measures. So basically the purpose of this calculation module is to see what amount of cooling demand in the city is actually being met by different technologies, what would be the size of these technologies, and what is the impact of development in the technologies with regards to the energy it requires to supply the cooling demand. And again, this can be done on different NUTS or different levels. I can stick to NUTS 3 because it takes a bit less time for calculations. And so I choose the city of Munich, and then the user is then able to select the sector they're most interested in, residential, non-residential, or both. So for now, let's choose both. And then the user can define the diffusion rates of space cooling technologies. So basically, this identifies the percentage of residential buildings that have cooling technologies. And again, the FEER, which is the efficiency of the cooling technologies, which, I mean, we can take base year values, but if you're calculating for the year 2050, then you could take much higher values, considering we expect improvement in the technology. And also we can based on passive measures, if we see potential uptake of passive measures in residential buildings at high rates, low rates, or no measures are implemented. And also similar can be done for the non-residential buildings. Here we see by default diffusion rates, or the number of percentage of non-residential buildings with cooling technologies is much higher. So we could always change this, but yeah, let's leave it here for now. And then, so the calculation module basically runs or takes three inputs. So it takes the input of the cooling degree days and the distribution of the gross floor area in the city for the residential and the non-residential sector. And if we run the calculation module, should give us an overview of how the demand in the city would look like, or how much energy would be needed in the cooling for the cooling sector. So it gives us an overview in gigawatt hours of the total energy demand for cooling, and how much residential area, or how many meter squares of residential area it covers. And in general also gives us the capacity, so the total peak of how much cooling would consume for supplying the overall cooling energy demand in the city of Munich. And yeah, this again, standalone could provide a good overview on the amount of energy that is needed, and we can see to the scale of which cooling can contribute to the demands in the overall energy sector, but also can provide as an input for different calculation modules. And also then maybe I switch a bit to the wiki now, where again, as I mentioned, we have quite a detailed description on how to use the individual calculation modules, but in general also on the CoolLIFE platform, how to use the calculation, how to use the platform itself, and gives us a good overview on what are the main applications of the calculation module. And if anybody is interested, of course, I would suggest to maybe work hand in hand with the toolbox and wiki, which provides quite detailed information and makes it a lot easier to understand the toolbox for a first-time user. And then we finished the demand calculation modules, but now we have some more interesting ones on the policy and finance. So to start with policy, so this calculation module is more of a, I would say, data for gathering information on different policies and regulations in specific regions. So for instance, now if I move to, let's say, for Milan, this is Milan, yeah. So we can see, so we go into the calculation module, and if a user is looking for information, for instance, on national strategies or governance, or we have different portfolio of combination of information available here. So for instance, if I want something on the national background and data on specific to cooling, which has been collected quite intensively within the scope of the project, so the user can have a look into what are the national policies with regards to cooling and what are its targets. So specifically here, it shows national targets for Italy, and also gives us quite good overview on what is the status and what needs to be done for further development of cooling sector in the country, or also in the region specific. And also with this calculation module, we go to the layers where we develop a additional file here, which gives us an access to the Excel file, which has much detailed information on the calculation modules. So if I just go to, just a second, I can show you this. And there we go. Yeah, so the user can download this file, and then here we have in the Excel file a very detailed assessment of policy level interventions for the selected region. So we have information on the NECP, the Comprehensive Assessment Building Regulations. So this is quite a heavy database, which could be very much useful for local as well as national planning. So coming back to the calculation modules, again, I would stick to here for now, let's say. And then the last calculation module we have is on financing or the mapping of financing instruments, which basically, again, allows user to identify potential financing options in their region, which could be interesting for further development of cooling plans and also implementation. So here the user can select on what kind of data they're looking for, also possibly, for instance, the type of schemes they're looking for. So let's say, for instance, we're just focusing on public schemes right now. And then, so if you run the calculation module, The calculation module provides, basically there are 10 different schemes that are identified for this region, public schemes identified for this region, and gives you a list of these public schemes, which can further be looked into detail if it really fits into the local planning. And also we have quite a detailed assessment study conducted on the financing tools, which I think now would be a good time to hand over to you, Giulia, for further looking into depth on the financing instruments. But for now, I think that was kind of the overview of the CoolLIFE platform, which is still under development.
Thank you so much, Aadit. Yes. So also the CoolLIFE platform is open access, the code is open access, the data is open access. I put in the chat a few links to the Citiwatts tool, to the CoolLIFE tool, to the CoolLIFE wiki. I put the link for our feedback form, and I'll continue on the mapping of financing instruments. So I'll share quickly my screen to show you where that comes from. In developing local energy, especially heating and cooling strategies, we came across a number of barriers, and financing keeps being one of the barriers. That means that whenever we develop a transition strategy, local administrations or energy utilities are telling us, yes, but who is going to pay for this intervention of decarbonization and optimization? So we started a couple of years ago, mapping all the financing schemes available at European level, and we still kept hitting the same barrier because at local level they were not considered enough. The local administration and energy planners that we were dealing with kept saying, tell me if I'm breaking up, in case I will switch off my camera if the internet connection is still not stable. They kept saying that the European level of subsidies and financing schemes was not enough. So we started this mapping at the national level. And the mapping has been funded by both CoolLIFE and SAFEA. Just to show you a couple of results of the mapping before we go back to the mapping in the tool and in the knowledge hub. Basically, we collected some 600 schemes, a little bit less than 600 schemes. Most of these schemes are public. Just a third are private commercial products. We have characterized per country, per type of scheme, public-private, per type of instrument. So if we're talking about loans, equity investment, guarantees, technical assistance, or a combination of all of these types. And we have also characterized them by the sector that the schemes are addressing. And here you can see is an overview of the overall mapping. From the overall mapping, we extracted two topic-specific data sets. One is the one that Aadit just used in the calculation module of CoolLIFE, that is specific for the private and public schemes supporting the decarbonization of space cooling. And another one is the data set that is developed by the project SAFEA, specific for geothermal energy in district heating and cooling. What came out of this mapping is that the first issue is actually collecting all this information. It is very rare to find a national portal that reunites all the schemes in one place. So this is why we created the dataset, and the dataset is open access. You can reuse it as long as you quote the authors. The type of instruments that we found the most often are traditional instruments, which doesn't mean that innovative instruments don't have any potential to attract private capital and to finance the decarbonization of the building stock. It just means that since they are more elaborated and more sophisticated, they are usually not offered as a public scheme, as a way of subsidizing the sector, but they can still be set up in a very successful way with special purpose vehicles. And of course, there are some sectors that are less targeted. So for instance, district heating and cooling is one of those, because it's more common to have few very large projects of district heating and cooling networks, rather than, for instance, a thermal renovation of a single or a multifamily house. We have also produced a few reports where you can see how the mapping was done. You can find all the resources, and they have been made available because the speed of obsolescence of this mapping is extremely high. So we carried it in February. It was peer-reviewed in March, and then it was again peer-reviewed in August, and between March and August, in just a few months, there was a difference of 20. It's important that any user has access to the resources and the links to be able to update the mapping in their region in case they need that. Let me go, I'll switch to the CoolLIFE. Okay, this is the CoolLIFE website, and I'll give you the link in the chat in a second. If it opens the chat. Can you still see my screen although I switched to the browser, or do you still see my presentation?
We see your browser now.
Okay, perfect. Good. So I put in the chat the link to the CoolLIFE website. And the CoolLIFE website, you can find, of course, information about the project and the different areas that the project addresses, and how we identify challenges, how we tackle them, and so on. And all the deliverables
Giulia,
of the project
maybe
that are
you
open access,
may turn off your camera.
you have the whole. Yeah, now it's the
a
moment.
little bit, yeah, exactly.
Just a second. Thank you. Yes, camera and screen share to be cool today. So thank you, Mostafa. Among the resources, you can find, for instance, a report on a status report of financing schemes, as well as the data set of a financing instrument. You find of various measures. There are a number of reports, and there will be more since the project is still ongoing until next year, end of November. And then you have a link to the tool, that is what we just saw, and you link to the Knowledge Hub. Now, the Knowledge Hub is a repository not of documents that were produced by the CoolLIFE project, but of other resources that we found particularly relevant for addressing the issue of a growing space cooling demand and wanting to meet the space cooling in a sustainable way. And for each of these resources, they are 50, so there were the 50 more relevant resources that we could find online at the moment. For each one of them, you find a page with some metadata describing what kind of resources we accessed. Now my internet is a little bit slow, so it's still opening the page. Yes. You see there is a link to the resource, the authors, the complete title, what kind of resource this is, a few keywords, and you can see if that can help you. Now, I told you that this mapping of financing instruments that we saw was extracted from a wider mapping, because this on CoolLIFE was only specific for space cooling. The complete mapping is accessible at this address that I will put in the chat in a moment. I will also show you how to navigate it. You can download it. Is an open access publisher of the mapping. It's not only available on Zenodo, but it's available also on the renewable heating and cooling platform. I'll put this address in the chat as well. So the renewable heating and cooling accelerator has a section that is in the accelerator repository of funding schemes. And if you open this part, you find one section dedicated to the European funding scheme catalog that is describing the various funding schemes that are available for renewable heating and cooling. And for each one of them, you find a short description and main facts and figures, and the link to access more information about that scheme. if you go instead in the national funding scheme, now here there is a link to the complete mapping on Zenodo, and there is a 15 minutes video that you can replay in case of doubt on how to use the mapping. And last but not least, the mapping also gave birth to a subset that is dedicated to geothermal district heating and cooling, which is available on the Safea Market Uptake Hub. I put the link here. So the Safea Market Uptake Hub collects a number of resources. Of course, again, description of the project. There is a knowledge base where we have a selection of resources, and also we have a selection of the deliverables of the project. So for instance, there is a scenario catalog where various geothermal resources in combination with district heating and cooling networks have been characterized and mapped throughout Europe. There is a report on market drivers for geothermal supplied multivalent district heating and cooling networks, and there are reports on the current business models and current financing instruments. There is a report on the current regulatory and policy framework across Europe, and then there is a literature repository. And then again, if you go to the section called Tools and Data, so the next one, Data and Tools, here you can find the report on the mapping of financing instruments. You can download the mapping of financing instruments, only those that are relevant for geothermal district heating and cooling. And the mapping is also embedded in the, I need to zoom out because, okay, I hope you can see it better. So the mapping is embedded in the website. As you can see, maybe, any chances? Maybe it's better if I open the mapping in Excel and show you directly that one. Just a second. Okay. It's opening. And now we'll have a look at the data set and how you can use it and how it can help you in your decision making of decarbonization projects. So I'll move it to the right screen. Good. Here you have a cover that quotes, of course, all the authors, describes what the mapping is about, and which tabs of the mapping contain what kind of resources. And then, of course, there are references to all the projects that funded it or that supported it. The mapping is divided in two main tabs. One contains the public schemes, and the other one, the private schemes. Now, open up. Looks like there is a filter on. Okay. So, okay, you can filter by country, of course. So there are the EU-27 member state countries, and there is also the European level, which is why in the CoolLIFE tool, when you were selecting which country you were interested in, you could choose if you wanted to see only the national schemes or also the European schemes, which of course are available for each member country. Then you can select the level. There are national schemes. There are also some regional and local schemes. On the national schemes, the level of accuracy is the level of confidence is a bit higher. That means that I can more safely say that in August, when we revised the mapping for the last time, we captured almost all the schemes. At local and regional level, it's much more likely that we missed something. The schemes are provided with the original title in local language and the title in English. And for each scheme, a series of sectors are mapped. So building efficiency, which means thermal retrofit of building envelopes, heating and cooling efficiency, heating and cooling renewable energy sources, district heating and cooling, and then specifically geothermal district heating and cooling for SAFEA and cooling for CoolLIFE. Then the schemes are mapped also against the type of building that they target, if it is residential or non-residential. They are characterized by type of schemes. So as we were saying earlier, you can have grants and subsidies, debt financing, so loans and soft loans, equity financing, a combination of them, guarantees, advisory services, and technical assistance, and so on. You have a series of links. There is a main link, and sometimes where relevant also a second link, a start and end year, and a short description of the scheme. So when you are looking, for instance, at a project of heating and cooling efficiency, improving distributed heating and cooling devices, let's say, you can see that these sectors are mapped either with a Y or with a Y in bracket. The Y is used when, yes, that sector is targeted directly. The Y in bracket is an indication. Potentially, the scheme could be used for that sector, although it's clear that that was not the main purpose. So it depends on your project. Just don't exclude it in the first round of scouting. Have a look at if that might be relevant for your case. In our case, we only want to go on the safe side. So we select schemes that are relevant for heating and cooling efficiency in a specific country. Let's say we go and look at France. And here we go. We have ADEME Green Loan, Prêt Vert ADEME. It's a debt financing scheme, so it's a loan. And here it's explained funding is offered in the form of a loan developed by ADEME, which is the National Energy Agency, and BPI France, which is a French bank, to encourage VSC and SME to undertake ecological and energy transition projects. Here there are a few indications of what is funded by this scheme, what are the eligibility criteria, if there are any indication on the funding rate or the minimum or maximum investment that is also reported. And then you also have the date on which this scheme was last visited. So in case you don't find it anymore, just be aware that that's why. And if the scheme was used to create data set exported for CoolLIFE or for SAFEA. The private scheme page is slightly different because for the private schemes, again, you have the name in local language and in English and the name of the bank. Why? Because most of the time what happens is that commercial products are provided for small investments. Larger investments require a B2B negotiation. But it's interesting if you are looking at developing a larger investment in a certain country to know which credit institutions or which investment funds are active in that country and have a commercial product for the decarbonization of the building stock, even though it's not exactly on the same topic of what you're looking for, because you know that that bank will have definitely a green finance or a green economy division, and you will find someone open to discuss your funding proposal. Again, the sectors are mapped, the type of scheme, some links, and a description of the scheme and the last visited date. On the page list, you see how we categorize the schemes so that you know exactly what we used. On the mapping sources, there are all the sources that I was mentioning. So there are sources as publications and databases at the European level, but also for each member state, there is a link to the National Energy and Climate Plan, to the Recovery and Resilience Plan, to the long-term renovation strategies, to the National Energy Efficiency Action Plan, to the building renovation national contact. And then if there is National Energy Efficiency Fund, it's linked here. If there is a National Energy Fund, if there is an agency like an environment agency or an innovation agency, the Ministry of Environment, and then other sources where most of the schemes were found. So that means that if you need to access this mapping in 6 months, and you look at the country or the region where you are focusing, and you see that most of the schemes are expired, how do you update that quickly? Come here, check these entities, and you're most likely to find what's new in that region on that topic, and also the keywords that we used for the desk research. Then we also provided some additional indicators and their sources. The indicators were economic, social, energy, and financial indicators. And we use because we created a correlation matrix to identify, yes, we created correlation matrix to see if there was any correlation between the various indicators. These mappings that unfortunately there is not very much budget transparency, which means that for private schemes, forget it. You will not find on a bank website how much funding are dedicated to a certain commercial scheme. Also because most of the time there is not a precise number. The product is put on sale and then on offer, and then depending how the market receives it, the decision is made on how much funding should be allocated to that scheme. When it comes instead to public schemes, well, there are some schemes that have an allocated budget from the very beginning, from the moment in which they are launched. There are some schemes that don't have that, and the budget is identified at the end of each year. There are some schemes that have an allocated budget, but it's not disclosed publicly. And others that have an allocated budget, but it's disclosed jointly. Improvements that this mapping could see in the next few months, together with integrating the mapping with additional let's say investment funds, pension funds, and hedge funds that are interested in investing in low carbon energy projects, specifically for the decarbonization of cities and buildings. I will now stop sharing my screen, and I wonder if there are any questions, either in the Q&A or in the chat, or if you would like to intervene. We still have a few minutes. Don't hold back. One last request that I would have for you is, since all of these are European projects, if you could kindly take a moment to fill out our feedback survey, that would help us very much improving the products that we are developing. For now, I still don't see any additional questions. I hope you enjoyed the session and that you will find these tools useful for your future work. Thank you to the Data Science Conference Europe 2024 for hosting us, and thank you to Mostafa and Aadit for their contribution to this online tech tutorial.
Thanks.
Thank you, Giulia Conforto, Mr. Mostafa, Mr. Aadit. It was very interesting to hear. And thank you everyone for attending the tutorial and being with us today.